Okay. So I think we are live on YouTube. So I'm just experimenting with this live broadcasting of our class. I think people who are not talking can mute themselves. Yeah.
कोई प्रॉब्लम नहीं सुधांशु,
So this is
सब बढ़िया।
basically
इसका स्ट्रीमिंग अच्छा लग रहा है।
yes, yes. Yeah. So that's what I'm just experimenting with this live streaming. So whatever the class we will be taking, it will be posted in YouTube in my account because this stream is linked to. So basically, that's what I'm trying to do, so that you can refer the classes later on if you have any doubts, and then just exploring this option to see how it, outcome how it will be. So I think yesterday we were discussing about some of the data warehousing concepts. Today we will continue with that. I think since all of you showed your faces, you can just hide the camera. We can directly move on to the class. Yeah. Yes. So just interact with me so that I'll come to know whether it is audible or not. Is my voice audible?
Yes, sir, it is audible.
Hello.
Yes, sir.
Okay, done. So
Yes, sir, it is audible, sir.
yes. So yesterday we were discussing about the some of the characteristics of DB, and types of DB, how data warehouse works, what type of data we will be dealing with, and some of the history related to the data warehouse. So continuing with that topic, today I will be discussing about again further more topics of data warehousing. Right. So there are three components, again, three-tier architecture of data warehouse is there. So three components: bottom tier, middle tier, and top tier. So the bottom tier is basically the database of the data warehouse. Again, the data warehouse itself contains the central database, so which acts as a server. So we call it as a bottom tier. So it is usually a relational database system. So what happens here is the data is cleaned, transformed, and loaded into this layer using backend tools. So again, you say it is called as a backend component, you can say. Then the middle tier in the data warehouse is an OLAP server, which is implemented using either ROLAP or MOLAP. So ROLAP is a relational online analytical processing, and MOLAP is a multidimensional online analytical processing. So in the subject, we will be dealing with the MOLAP instead of ROLAP actually. So then for user, this application tier presents an abstract view of the database. This layer is also acts as a mediator between the end user and the database. So the name itself says, so to connect from the front end to the back end, we use this middle tier component. Then top tier is front end client layer. The top tier is the tool or the API that you connect and get data out of from the data warehouse. So this is top tier is basically this Visual Studio, you can say. A lot of top tier tools we will be using so that you can create those reports from the database. So it could be query tools, reporting tools, managed query tools, analysis tools, and data mining tools. So the top tier consists of all these front end tools. So basically the data warehouse is implemented in these three particular tiers. So we call it as a three-tier architecture. Coming to the overall picture of your data warehouse, so you can see a lot of components are involved. So you can see this is a backend component, then this is a middle tier, this is the front end tier. So here transaction databases will be there, operational databases will be there, external databases will be there. So you apply ETL tools to them. ETL tools, I told you, extract, transform, load. Then you clean the data, transaction data. Then you store those particular cleaned data and transaction data into the central database server, that is data warehouse warehouse database, we call it as. So along with that, you also storing metadata. So here is the place where all your data warehouse important data will be stored. Then in order to access the values present here, we are using some of the query tools. So those are nothing but data marts, reporting and analysis and mining tools. So what is the outcome of these things? You will get interactive reports, ad hoc reports, static reports. So this is basically overall picture of your data warehouse architecture. Coming to the differences between database and data warehouse. Okay, so parameter, I have just taken some of the important differences here. So parameter, database and data warehouse. So what is the purpose of the database? It is just used to design, it is just designed to record the values, so it is not doing anything else. So if I want to say I want to store students marks details in the backend, so I will just store them. I'm not analyzing them, I'm just storing the data. But data warehouse is for analyzing that data which is already existing in the database. Say for example, how many students have scored more than 70%, how many students are failed, how many students are passed. So percentage we can calculate. So that is the job of data warehouse. Then processing method, the database uses the OLTP. So this is one of the important difference which you need to know. So database uses the OLTP transaction method, data warehouse uses OLAP. So this is the important difference. So OLTP and OLAP I'll explain in detail later on. Then tables and join operations. What kind of tables and joins operations we do? So in the database, tables and joins of a database are complex as they are normalized. So yesterday we were discussing about this normalization concept, right? Where we are trying to remove the redundancy. So here in the database, we try to remove the redundancy by applying the normalization technique. So obviously the functions will be complex. But in the case of data warehouse, tables and joins are simple in data warehouse because they are denormalized. So obviously you are, again, whatever the data you are collecting from multiple databases, you are denormalizing them so that you can analyze them. So that is called as the denormalization. Then orientation, database is an application oriented collection of data. Data warehouse is a subject oriented collection of data. So obviously in database you store the data related to the particular application. Say for student data, that is one particular application. But data warehouse, it is a subject oriented. So it is basically to analyze what is actually going on in the organization, say finance, revenue. So all those things, it is called as a subject oriented. Then storage limit, generally limited to a single application. Here the stores data from any number of applications. So here you cannot simply put all the data from different databases, different data sources, and put them into the database. Here it should be a single application oriented, but in the data warehouse you can combine the data from the multiple data sources. Availability, in the database it is available in real time. In data warehouse, data is refreshed from source systems as and when it is needed. So again, here we are storing the historical data, not the regular operational data. So obviously here we can refresh the database and check whether is there any new data has been added to the data warehouse or not. So it is basically historical data we are storing. Then the storage of data, flat relational approach method is used for data storage, but the data warehouse uses dimensional and normalized approach for the data structure. So what do you mean by flat relational approach, and what do you mean by dimensional and normalized approach? So I have given the example here as star and snowflake schema. So yesterday again I asked about what is star and snowflake schema, and anyway I'm going to discuss about that topic in detail. If you have any idea about, if you have learned in database, what do you mean by flat relational model and dimensional model? Anybody?
No, sir, no idea.
How do you store normal data into the database? Rows and column wise?
Yes, sir. Tabular
Okay,
format.
for example, if I want to store student marks, how will I store? I will create a student name as a row wise and column wise subject marks. Like for example, how much marks for cryptography, how much marks for dbms, how much marks for uh, artificial intelligence. So these are three subjects. So this will be put under column, then students names will be put under rows. So that is the traditional approach for storing the data in the database. So we call it as a flat relational model, where we are storing only using what number of rows and column wise. But in data warehouse we use the dimensional model. So dimensional model is model is, again, I told you about dimensions and facts, right? So there will be a facts value or the measures using which we create a number of dimensions. So those dimensions will be related to the central fact table. So we call them as the dimensional models. There are two, three types there: star, snowflake, and galaxy schemas. So I will discuss about those topics in detail in the coming slides. Then applications of the database, just for your understanding where and all it will be used, and usage. Okay, why this particular topic is important here is because database is also there and data warehouse is also there. Why we need two separate things here? Because both of them are doing their different jobs. They are not related. The data is stored in both the databases as well as data warehouse, but what kind of data is stored, that we need to understand. So here, sector and usage. So banking sector, make what and all we can do using database. You can take customer information, account related activities, payments, deposits, loans, credit cards, etc. In airlines, uses for reservation and schedule information. Universities, to store student information, course registration, colleges and results. So many things you can do. In telecommunication, call records, monthly bills, balance maintenance, and all those you can do. Under finance section, you can store information related to stocks, sales, purchase of stocks and bonds. Under sales and production, you can use it for storing customer, product sales and details. Under manufacturing section, it is used for data management of the supply chain, for tracking production of items, inventory status. And under HR management, you can take about employee salaries, deduction, generation of paychecks. So you can do a lot of day-to-day operations using database. So as you can see, all these usages are day-to-day operations. They're not something historical data. As and when the data is there, you are updating into the database. So these are some of the usages of the database based on the different sectors. Now coming to the applications of the data warehouse. I want you to analyze what is the difference you can see compared to the applications of database and data warehouse. So you can cross examine with the applications of database and data warehouse in the particular sector of airline. So in the airline C, it is used for airline system management operations like crew assignment, analysis of the route, frequent flyer program, discount schemes for passenger, etc. So is there any difference in the usage of data warehouse for airline section and for the database section? So here you see, under airline sector, database used only for what purpose? Used for reservations and schedule information, nothing else. But for data warehouse, you're doing a lot of analysis part, right? What exactly you are analyzing here? Operations like crew assignment, in detail analysis of the route, then frequent flyer program, discount schemes. You are going to give some of the discounts to the users. So you are analyzing what target customers I need to choose for this particular discount, what route I should be choosing. So you are analyzing a lot of things here. Similarly, for banking sector, you see, it is used in the banking sector to manage resources available on the desk effectively. So what kind of resources needed, what kind of resources are already there. So all those analysis part you are doing using data warehouse. Under healthcare sector, you are predicting outcomes, create patients treatment reports, and all those things you are doing. Under insurance sector, you are using data patterns, customer trends, and track market movements. So in stock market, it will be very much useful. Under retail chain, you are tracking items, identifying the buying patterns of the customers. So this exactly is done by Flipkart and Amazon, right? They will ask you to choose some of the no items which they are suggesting based on your buying pattern. So that and all you can do using data warehouse. Again, promotions you can do, then use for determining pricing policy. So this pricing policy is important because they'll compare different sites and check what exactly is the price for the same item. So what is the policy I need to follow for fixing one particular price for an item. So that you can do using data warehouse. Then telecommunication, you can use it for product promotion, sales decisions, and to make distribution decisions. So again, where exactly you can cover the area, geographically you can cover the area so that your growth will be higher. So all those things you can do. I mean, analysis, basically the analysis part you can do using data warehouse. So all this usages you can see, they are not day-to-day operations. So you are using the historical data which is already there, and you are analyzing and trying to find out what could be the decisions I can take based on this particular analysis. So that is the main difference between database and the data warehouse. Okay, so do you have any doubt till now?
No, sir.
Okay, so moving on with the
Carry on.
next concept. Yeah, so I was talking about this what is flat relational model and what is multidimensional model, right? So now I'm going to discuss about what is multidimensional data model. So multidimensional schema is basically designed to model data warehouse systems. Okay, again, so you are not using flat relational model in the data warehouse system, so you need to remember we are using multidimensional model. So what are the multidimensional model schemes? So the schemas are designed to address the unique needs of very large database designed for the analytical purpose. Okay, so if you want to do OLAP operations, so obviously you need to use multidimensional data models, you cannot use the relational data models. So what are the three types of multidimensional data models? So there are star schema, snowflake schema, and galaxy schema. So I'm going to discuss about briefly about these three topics. So before going to those schemas, I'm just showing you one of the table which we call it as a flat relational model table. So I was giving that student marks example, right? So here you can see there is a patient ID, then there is a patient name, date of birth, gender, phone, doctor ID, doctor, and some room number. So this is called as a flat relational model where based on the row and based on the column you are storing some data, right? So obviously this patient ID is related to the entire columns. So one row is mapped with the how many columns? 1, 2, 3, 4, 5, 6, 7. So one row is mapped with the 7 data, right? So this is called as a flat relational table where just like creating a matrix, we store data into the database. Now coming to what is star schema, right? I told you, right? There is a dimensional table and there is a fact table. So fact table is the key table which has links to all these dimensional tables, and it also has its own set of measures to calculate some of the values, right? So fk means what? Foreign key. Pk means primary key. Then how many dimension tables are there here? 1, 2, 3, 4. Four dimension tables are there, and this is a fact table, right? So what are the values stores in the fact table? You see there is an item key from this item table. Okay, so obviously this item key becomes the foreign key in the fact table, right? Then there is a time key, time ID, right? Then there is a branch ID, then there is a location ID. So branch ID is this particular table. So again this branch ID becomes foreign key in the fact table. Similarly location ID becomes foreign key in the fact table. Then apart from these four primary values, it is also having its own set of measures to calculate or analyze the data. So what are they? Quantity sold, amount sold, then average sales, right? So these particular four values are coming from where? These individual dimensional tables. Again you can see these individual dimensional tables have their own dimensions inside. So time ID is the primary key here, then day, month, quarter, year. So if you want to look for an item, on which day, which month, which quarter, which year that item is sold. So if you want to analyze that part, so what you do, you refer this timetable, and here all the in detailed analysis of that particular item will be present, right? So you give the time ID, then based on the time ID and the item key you will get all this information on what day, what month, what quarter, what year that item is sold. Similarly location dimension table. So if you want to find out where exactly that item is shipped or where exactly that item is bought from, you can give the location ID. Then there is a name, state, pin code. Similarly item key, item name, brand, sold by, category. Similarly branch ID, branch name, owner. So this fact table is not collecting the all the data by itself. So what it is doing, it is referring the individual dimensional tables. So once it refers it, it has its own set of measures. So using all this reference, it will come to know about how many quantities of items sold, what is the total amount is gained by selling all those items, then average sales. So analysis part is done by the fact table. Actual data will be provided by these individual dimensional tables. So this is called as a star schema. Why it is called as a star schema? Because there is a central table and all the dimensional tables surrounded by it. So it represents a structure like star. That's why it is called as a star schema. Any doubts you have here?
No, sir.
No.
Have you learned this particular schema in database?
Yes, sir. Like
You had it.
we heard the name, but didn't go in detail, I guess.
You had a subject, right? Database. Yeah.
Yes, sir.
So moving on, I'm giving an example of snowflake schema. The next schema. So I want you people to interact and analyze what is the difference you can see compared to the star schema and snowflake schema. What is that exact points you can figure out and look into this particular figure. What are the changes we can observe there?
It is some similar to that of star schema, sir, but the dimension tables have some extra tables linked to them.
Exactly. So how can you define this particular schema based on your observation? So can I
Sir,
say there is
it is like
only,
a tree.
yeah. So can I
There
say
is a
is
main
there
branch.
yes, yes. So
And sir, then we
again,
have sub branches of it.
exactly. So basically, again here there is only one fact table, obviously, but the dimension tables can be further divided into a number of dimensions. So there is no restriction that the dimension table should be existing by itself alone. So you can divide the dimension table further into a number of dimensions. So based on that observation, you can see here the fact table is having the name as revenue. So it is having the primary keys of each dimension tables, dealer id, then here date id, model id, product id. Then apart from that, it has its own measures, units sold and revenue. Okay, so coming to this particular dimension table, this particular dimension table is further divided into two dimensions. Here there is a dealer id, then location id, country id, dealer name, dealer contact. But what is missing here is uh, location id is there, but in detail information about the location id is not there, like what is the region, what is the state, what is the country. So again, you can further divide this particular dealer table into two dimensions. So you can give the name as location dimension table and country dimension table. So you can again assign individual primary keys there. So location id will become a primary key, here country id will become a primary key. So these two values you can give in the dimension table. So similarly, here the variant id under product dimension table is further divided into what is the variant name, what is the fuel type. Okay, so this is the example of snowflake schema. Again, it is derived from the star schema, but the only difference here is that you can divide individual dimensional tables into a number of dimensions as and when you want it, you need it. So it is called as a snowflake schema. So snowflake schema, why it is called as a snowflake schema? Again, you can see the pictures of snowflake. Have you seen snowflakes? So it does resemble that particular structure. So you can google it out and see what is the structure of snowflake. We'll get to know. So here I'm discussing about the features of star schema and snowflake schema. So as I explained, the star schema, the center of the star can have a one fact table and a number of associated dimension tables. So it is known as a star schema as its structure resembles the stars. Then what are the characteristics of the star schema? So every dimension in star schema is represented with only one dimensional table. So this is the main difference between star schema and snowflake schema. So there is only one dimensional table. The dimension table should contain set of attributes. So what are those attributes? What are the attributes? Here, dealer ID, location ID, country ID, dealer name, dealer contact. So these are called as the attributes of dealer table. And dimension table is joined to the fact table using foreign key, right? Have you seen this particular example in the diagram? The dimension table is joined to the fact table using the foreign key. So how you are linking the dimension table to the fact table? Using foreign key. Then dimension tables are not joined with each other. So again, this is important. You cannot combine two dimension tables and give one primary key for those two dimension tables. So you cannot do that. Individual dimensions should be having their own set of primary keys. Then fact table would contain key and measures. Again, these keys basically in the foreign keys of individual dimensions and its own set of measures for doing analysis. Then star schema is easy to understand and provides optimal disk usage. The dimension tables are not normalized. So this point again, the dimension tables are not normalized means what? There might exist a redundancy in the dimension tables. So you are not going to concentrate much on that. Yes. There is one more schema, galaxy schema. Again, I want you people to observe this particular diagram and explain me what exactly is going on here. Anybody? Hello? Are you able to listen my voice?
Yes, sir.
What is the difference you are seeing here compared to star schema and this one snowflake schema? Quick.
Repeat the question, sir.
What is the difference between galaxy and the snowflake schema based on this observation of this diagram? What exactly you can find out?
So we don't have a centralized branch, I can say.
Okay. Others? Is that right?
Rahul wants to say something, sir.
Say, Rahul.
So he's at backstage. He's not able to communicate with you.
Oh, okay, okay.
Yes, sir.
Yeah. Now I have
Mm.
added to Rahul. Why Rahul? What happened?
Actually, I'm using in phone, sir. Once if I press back button or something, also it is I'm exiting from the call, sir. Live.
Okay, it is exiting by itself, huh?
Yes, sir. If I press once back button to go somewhere, also it is
Okay,
exiting,
okay.
sir.
सुधांशु तुम्हारा क्या प्रॉब्लम हुआ? परमिशन ग्रांटेड है ना माइक का?
He was saying that.
Yes, yes, permission granted है सुधांशु. See here, I have unmuted you. I mean, it is control is based on you only. We will see. We will explore if if there are any settings we can do. We can see later on. This is just we are trying it. अगली बार देखते हैं क्या क्या इश्यूज आ रहा है. तुम नोट करके रखो. राहुल का ऑटोमेटिक एग्जिट हो रहा है. सुधांशु तुम्हारा क्या प्रॉब्लम हो रहा है?
सर ऑटोमेटिक एग्जिट नहीं सर, मतलब बैक स्टेज चल जाएगा अगर हम लोग कुछ बैक या फिर कुछ करेंगे तो.
ठीक है, ठीक है,
वैसे सही है सर.
ठीक है. राहुल, यू वांटेड टू से समथिंग?
तो मैं बता रहा था कि आई एम नॉट एबल टू गेट एनीथिंग फ्रॉम दैट इमेज diagram, sir. कुछ relate नहीं कर पा रहा हूँ.
Okay, I will show you the snowflake schema here. Now just observe snowflake schema. Okay, this is your snowflake schema. This is your galaxy schema.
Yes, sir.
Hmm. So what is happening here? So until now, in star schema and snowflake schema, there was only one central fact table. So Subodh actually said that point. There is no one particular central fact table here. You can have a number of fact tables, right? So here there is one fact table called as revenue. Here there is one more fact table called as product. And what is that one more difference you can see here is individual dimension tables. Individual dimension tables can have the reference for two or more fact tables. That is the point I wanted to tell you. So here you see this particular dimension table branch dimension is basically have the connection with the fact table of revenue also and product also, right? So branch id is there, then product id is there, so they are interlinked basically. Similarly, date timetable is interlinked with this particular fact table and this particular fact table. So you can have n number of fact tables, and individual dimension tables can refer this fact tables separately. Okay, so unlike in snowflake where there is only one fact table and a number of dimension tables, here you can have a number of fact tables and a number of dimension tables referring the individual fact tables separately. So that is the difference here. And a galaxy schema contains two fact tables that share dimension tables between them. See here. So it is also called as a constellation scheme. The schema is viewed as a collection of stars, since the name is called as a galaxy schema. So what are the characteristics of galaxy schema? The dimensions in this schema are separated into separate dimensions based on the various levels of hierarchy. So here I've given the example. If geography has 4 levels of hierarchy like region, country, state, and city, then galaxy schema should have 4 separate dimensions. So you can create individual dimension tables for based on these 4 levels. Then dimensions are large in this schema, which is needed to build based on the levels of hierarchy. So a lot of dimensions will be there. So based on levels of hierarchy, you can create multiple fact tables and multiple dimension tables. So this schema is helpful for aggregating fact tables for better understanding. So aggregating fact tables means you can combine the data from multiple fact tables for effective analysis. So this is basically I wanted to discuss about a brief overview of what are these different dimension tables which we will be dealing with. Why those concepts are important is, end of the day you are storing the data in the database. So how you store the data, it matters. So it can be one of those three models. It can be star schema or snowflake schema or galaxy schema. So next topic I'll be discussing about is ETL process. ETL, I think I have given the brief again introduction about this particular ETL process. So what is ETL? ETL is a process that extract data from different source systems, then transform the data. So it can apply a lot of calculations, concatenations, etc., and finally loads the data into the data warehouse system. So what is the full form? Extract, transform, and load. So again, how you are storing the data from multiple databases into the data warehouse. So that is using ETL process. So in that main diagram I showed you, right? Where is that three-tier architecture? Yeah. So here you see there are a number of databases which you can take as a reference. Then you apply ETL tools. Then only you are storing the data into the data warehouse. So before applying ETL tools, you cannot directly combine the sources from multiple databases and store it in the data warehouse. So ETL plays a very important role here for performing a lot of calculations, concatenations, transformation, cleansing. So all such operations will be applied by these ETL tools. Okay, so again see here there are a lot of servers will be there: Oracle, SQL Server, Teradata, flat file. So basically these are individual heterogeneous databases from where the the ETL is collecting the data, so we call it as a staging area. Then from the staging area, it goes into the data warehouse. So like this, we will be doing a lot of calculations, concatenations using ETL system. So there are three phases again, as I said: extraction, transformation, and load. So what do you mean by extraction? So in this step, the data is extracted from the source system into the staging area. Okay. Then the transformation, if any, are done in the staging area, so that performance of the source system is not degraded. So transformation means what? Basically, what kind of data you want to take, or do you want to remove any number of rows or columns, or the way the data should be stored. So all those alterations you can do in this transformation phase. Then staging area gives an opportunity to validate extracted data before it moves into the data warehouse. So you can validate the extracted data, whether it is corrupted, whether it is having any spam data. So all those validations you can do before the data actually is stored into the data warehouse. So what are the some of the validations are done using extraction phase? So reconcile records with the source data. So what do you mean by reconcile the records with the source data? Basically, suppose you say you have three databases: student database, employee database, and you suggest me some finance database. Okay, so you are combining those three database values and storing it into the data warehouse. So what you need to reconcile? Basically, the data which you are referring from the student database, employee database, and finance database, is it the genuine data, original data which you are actually storing into the data warehouse? So you are matching the original data and the data which you are going to store in the database, whether it is corrupted, whether it is having any ill values. All those things you are comparing. Reconcile is basically comparing with the existing data before it is actually stored into the data warehouse. Then make sure that no spam, unwanted data is loaded. So as I was mentioning, so you will make sure that there is no unwanted and spam data is loaded into the data warehouse. Then data type check. What do you mean by data type check? Whether the format of the data is stored in the correct way. Because for example, integer data, so there should be integer values, means decimal, float, all those things you need to check. For character data, you should be checking the data type for string and char. So you are doing the data type check with the source database. Then removes all type of duplicate, fragmented data, right? So again, if there is any duplication of the data, fragmented data means the data which is fragmented here and there. That means basically, say I have one data, student marks data I have. It is having the two columns. It is having only marks for two subjects, right? So again it is repeated somewhere else. So data is basically fragmented, means for one student you are having a number of table references. So that need to be taken care of. So you cannot have one id and a different set of values for that one id. So this fragmentation you experience even in the operating system, right? So you store some values into the hardware. Again, if you're not doing the defragmentation, that particular set of hexadecimal values of the uh, disk will be unused. So you can explore that fragmentation concept which we have studied in the operating system. Then check whether all the keys are in place or not. So what keys we are talking about here? Whether primary keys and foreign keys, all those are mapped properly or not to the fact table. So that is called as a keys. Check whether all the keys are in place or not, with actually in the reference of fact table I am talking. So these are some of the validations which will be done using extraction phase. So similarly, we have a what phase? Transformation phase and loading phase. So I will discuss about those two techniques and further concepts in the tomorrow's class.